We're going to keep on talking about how digital technologies, how data and especially AI is shaping big companies. And in order to do so, I'm going to welcome Martin Baier on stage, or Dr. Martin Baier here on stage, who did his PhD here in Aachen. Yesterday evening we talked about it in astrophysics. I still didn't get it, but it's something about high energy particles. So after that, changed into data science, or developed into the data science, used his theoretical foundation to really generate then value at LANXESS, and is currently cluster lead software development and data and AI platform, and is going to tell us how he is leveraging the data and AI for strategic decisions at LANXESS. Please join me on stage.
Thank you for having me here as well.
Yeah.
And thank you for the nice introduction.
All right, stage is yours. Enjoy.
Thanks. Cool. So also welcome from my side. And I guess I don't need to introduce myself anymore, but let me quickly introduce LANXESS as a chemical company. And as a chemical company, we are producing a variety of chemical products, disinfectants, bases for colors, water purity, and so on. And with that, we have a big amount of challenges in front of us. And we are actually trying to use data as much as possible, and obviously also AI, to come up with strategic decisions at LANXESS. And there's one event in the past where our capabilities to react fast with data became actually really important. And this is this event here. As I guess many of you might actually remember, there was a ship, the Evergreen, blocking further traffic through the Suez Canal. And first question for us was, well, which of our containers are actually on that ship? Next question, which other vessels which are blocked now by this ship have to go around Africa? So looking into what is actually going on and how can we deal with it. Next thing is, which customers are affected, and can we eventually produce the products that they want to receive in a plant somewhere else in the world, and so on. So there was lots of discussions going on, fetching data from actually carriers and so on, getting external data, enriching our internal data, and so on. And that brought us to thinking about how a maturity model on decisions can look like. And this is the model we came up with, from the left-hand side actually being the past, to the right-hand side being the futures, and somewhere in the middle it's the now, the point in time where we are right now. And let me start on the left-hand side. The first question I asked already, what happened actually? And that is descriptive. Look at standard reports. That could be also like EBIT increased, decreased, whatsoever. Customers are buying less. Next step is then, also in the past, still diagnostic. Why did something happen? And that is mainly through interactive dashboards. And there are typical reporting solutions and interactive dashboard solutions, which of course in use in our company. And these diagnostic things could be the energy prices, for example, increased. So the price of our products have increased, and therefore maybe customers are buying less or going to other providers or whatsoever. Now looking more into the future is what might actually happen doing predictions. Think about regulations that we have around, especially chemical industry, sustainability as a topic we heard of quite often today. Also thinking about demands in different, let's say, sectors or regions in the world and so on. So this is more towards AI-based forecasting. And there are standard methods, but there are also more advanced approaches, I would say. Last thing is, what should we actually do? So not only what will happen, but what should we do with those predictions? And that would be prescriptive, thinking about recommendations. And that could be, how can we actually adjust our production processes to increase the yield at lower energy consumption, or reduce the waste that is produced always, and so on. So these typical questions we are looking at, and think about predictive maintenance, for example, where you want to stabilize your operations in production in the plants to make sure the plants are used as much as possible, and there are, well, only small downtimes. And thinking about that, that brought us then actually to a setup of ingredients, and there are a couple of ingredients. On the top, there is actually the culture. You need to have a culture inside the company that allows actually to do data-driven decisions, that allows you to use also AI to play around. I will come in a second to that. Obviously, data-driven decisions without data, well, data is the new oil. I don't need to say something about that. Technology is definitely an important point, and we heard this also in the previous talk. Technology is one ingredient, but not the only ingredient. Skilled and interdisciplinary teams is one of the next ingredients. And last but not least, there are business objectives, there are business goals, and there's executive sponsorships, and there's a way how to measure actually success. And I will use this slide and use it as a, well, navigation for the next through a few slides. Let me start with business objective and executive support. First of all, there has to be a business strategy around data, around AI. And that is actually, there's a whole department, corporate development, which is responsible at LANXESS to think about what data and AI initiatives will support, and also why they should support something. This could be, for example, revenue growth or operational efficiency or other things. We then break it down into more long-term and short-term targets that we want to achieve, and try to get an executive sponsor for each of the milestones of these projects. With that, you have always an alignment with the priority among the company strategy, so to say, and you also have lighthouses because these executives obviously have, let's say, a big community. Last but not least, you start with lighthouses because you have to start somewhere. If it's successful, then you have also to celebrate that success and basically spread the news inside the company that things work, to also reduce the resistance that I would say naturally exists against something new. And AI, I would say, is definitely something new. And there are also some people panicking around it. The other thing is, and that is one of the really important things, is how can we actually define success and think about how to build in also failures into the overall process. And that is really important because especially, I would say, press is saying AI is a success here, AI is a success there, and you get flooded with positive messages around AI, but practically the value is not everywhere there. And we saw some areas, especially in the machine learning area, where we saw bigger benefits around AI, but also some areas where, well, the usage is obviously not so performant, I would say. One of the big learnings we had here is we need to be flexible to change our path and eventually to identify new targets on the way. And that's an interesting part because the implementation of data and AI use cases is in the information technology department, mainly, I would say. And the strategy is more in the corporate development department, or group functions actually. So there has to be a communication between. Coming from the flexibility actually to the culture, there are three main pillars. Obviously, we're talking about data and AI-driven decisions. So a data-driven mindset is, I would say, naturally. You need to have that. Not everybody has that. So we start actually with a community of people who are curious, who want to learn continuously something, who want to experiment, try out something new, and also love to have evidence-based decisions. In, I would say, chemical industry, you have very often the word, well, we did it like that since 100 years, 50 years, whatsoever. Why should we change it? It works already. But sometimes trying out something new might bring improvements. Sometimes it does not, but then we have at least a learning. Training and communication. We have roadshows all over the world. We have groups that meet in individual domains, for example, marketing and sales, that actually go for knowledge sharing. One has also to train people on risk. AI is not doing everything right. And that is something, just think about a plant. Do you really want a chemical plant, to be operated by an AI? I personally don't trust AI that much, although I've implemented quite some models. So trust in common sense is one of the important things. Last but not least, building the fail fast approach into our environment is one of the things. And let me explain you one of the use cases where we do that. We use AI to develop new chemical products. And we have AI built into the loop. So AI actually proposes new recipes. We test those new recipes. They might be good, they might be bad. At least we learned something around them. We retrain the model, we repropose new formulations, and we iterate around that. So the failure is built into this process, which we call sequential learning overall. And that is motivation because you get better and better in each iteration. And out of that, we have actually created a handful, almost, new patents and obviously new products that are on the market to be bought. The teams is a really important part, and I'm leading the technology/data platform team, as mentioned already in the introduction, and this is just a small team. They are focusing on enabling everybody else who's above, and you can see the sizes of the bars, they get even bigger and bigger. This is equivalent to the amount of people being supported there. And the next layer that we have are data engineers, data scientists, analysts, Gen AI developers, and so on, who work on the platform. And I'm going to say something about the platform in a second. But it's really important to have these 3 different layers here. So above the data engineers, we have the domain experts, and they are somewhat similar to the data professionals, I would call them. They are typically either people coming from the business with a lot of interest in technology, or people who come from a technology area and having specialized in certain domains. So we treat them somewhat different as the data engineers who have a more technology-based focus. And obviously, in the end, an AI is only, or a data-driven approach is only useful when it works for the business users. And that means that it needs to work smoothly. Just think about Google Maps. You put in your starting point, you put in your destination, and it gives you something, and that's it. And you just use it naturally. You don't have to click here and there and so on. So it has to have something that is usable in the end. Myself, being the lead in the technology and data platform team, I of course can talk technology-wise pretty deep about the data platform, but let me just say a few words about it. First of all, we decided to build our data platform in-house to be a technology enabler and also to be an implementation accelerator. And the challenge here was to find a good middle ground between standardization and flexibility for the developers on one hand, and on the other hand, security, governance processes, and things that you want to have handled centrally. One of the key achievements is that we have a low effort to get from development to an operationally working use case or application in the end that is then used by the business. And on the other hand, we have an agreement with our compliance and security departments that if the setup within the platform is used, then at least some basic criteria of security and compliance are guaranteed. And that is a big disadvantage over developing into the wild, which is seen in many other companies. We started the project in 2020. It's well established since then. And in 2023, maybe 2024, we actually put on top of our central data platform, we put Gen AI and also more features related to machine learning. So our approach was actually, let's have a central data platform first, where we can work centrally on, and then put AI on top, because AI doesn't work without data. AI is just a tool. The platform itself, it deals with data sets, obviously. It has the possibility to train models, to transform data, but that's not useful without applications. And there we also went for something that is standard, an industry-wide standard. And one of the goals was also not to achieve login, but rather give the people some boundaries which are flexible, which are governed, which are secure, but nevertheless, if they don't want to work on the platform, then they don't have to, they can also use something else, but then they might have to go through security tests and so on. Obviously, security is built in, also identity management and a couple of other things. And last but not least, a really important part for us is the lineage. We've actually published a software patent around lineage analytics. And this lineage is a tool that allows us to see how the data flows through the system. And you can think of a company like LANXESS. They have various ERP systems. They have lots of different data sources. Just think about production systems, lab systems, logistics systems, and so on and so on and so on. And there's, of course, external data sources as well on the market where you might want to buy data from and use it for your internal analytics. And to keep track with a couple of 10,000 data sets on the platform, how the flow of data is happening, what is impacted, but also to see who has access on what, when was something refreshed, and I don't know what. So typical governance, also controlling things. This is the central tool, and the lineage has become more and more important. Also thinking about Gen AI, because we know how the data flows, well, this information is somewhat relevant for Gen AI use cases when you want to do things like talking to your data. Well, I talked a lot about people and the platform. I didn't talk about data yet. LANXESS itself, we have so many different systems. We had so many silos, which is maybe also due to the history of the company. But I feel it's somewhat natural. It's my data, so I keep it for me. And opening those silo boxes is one of the really important parts. And basically connecting everything, bringing it together on one system, making it accessible, making it nevertheless secure so that only the people who should have access can access the data. That's one really important part. The data quality is obviously, I would say, very often a nightmare in the beginning. And I myself have worked in projects where there were chemical ingredients consisting of actually just one letter and two numbers, each repeated twice, so 6 characters in total, but I found 10 different spellings of this thing. And you can imagine that this is for AI a nightmare, especially if upper and lower case have different meaning eventually. And we have centrally established some data quality tools. We have a medallion architecture where you come from raw data, go to gold or silver or whatsoever you call them in the end, which are then ready to be used by the end users in case they have access. Data accessibility can be enriched with data discoverability so that people can actually see that some sorts of data exist, but maybe they don't have access, but they get an idea, okay, maybe I can use this to improve my current situation. The governance around is centrally managed. As I said, our main tool there is the lineage that we developed. And just to make sure that everything is as it should be, 4 I's principle is followed. Also, we work on use cases. We have a data classification process where data is classified as, I don't know, confidential, but then you might have use cases where you bring together multiple confidential data sets. And with that, you might turn up into a secret. Let me give an example for you. Think about chemical processes we have. They are internally classified as confidentially. Then on the other hand, you might have plant sketches, the architecture of plants. They are also considered as confidential. But as you might guess, if you have both of them in your hands, then you have a secret in your hand. And that has to be treated carefully so that you can also do a risk assessment. And that brings me to the last slide and the learnings that we have. If you want to have data-driven decisions, then this is only possible if you go for a collaborative approach, if everybody is on board, from people being technology focused over people actually implementing individual use cases, up to the business using tools that allow us to do data-driven decisions, and of course surrounding a culture and having executive sponsorship that also shows as a lighthouse what is actually going on. you need to observe technology trends and eventually use state of the art. Not stay too much behind, but maybe use state of the art whenever it seems to be relevant. Constantly question what you actually do. Think about, is this really needed? Can I go back to something classical, or does it have to be AI? Or can it be a simple decision-based tree thingy whatsoever? And last but not least, for me personally, and that's a really personal statement, having a reliable and flexible platform that grants some guardrails to everybody working on the platform, but gives everybody enough flexibility, and definitely no lock-in, as you see with many companies offering platforms.
Martin, thank you so much for giving us these insights and for telling your story about how you also built this platform. And I just had to write down a quote. You said, "I don't trust AI." That's quite a statement for a person being responsible for the AI platform. Maybe elaborate a little bit. I mean, you did during the keynote, but what are your personal experiences?
So first of all, maybe from my background as a physicist, I've dealt a lot with AI, and I mean hallucinations in Gen AI-based models. That's I think nothing I need to mention. And there might be obviously wrong things which might sound right, but you can also go to machine learning where things predict something. Just think about a model. It predicts something, use those ingredients, and you have your perfect chemical formulation. Yeah. But this AI has never studied chemistry, never had the experience to sit in a lab and actually put some chemical ingredients together, which might, I don't know, blow up or turn into a smoky situation. Yeah. And this is just small scale. Think about big scale, large scale, thinking about a plant, and think about that being operated by something which might have, I don't know, only 1%, 2%, and we know for hallucinations it's way more of error rates. Yeah. I don't know if I want to have, or if I want to be in Leverkusen, Dormagen, wheresoever, and something that makes too many mistakes, and 1%, that means 3 to 4 issues per year in a chemical plant. I think typically you have like an issue per, I don't know, 10 years, 50 years or so. That's the current status that we have. So we are not yet there with AI. Okay, I see it as a tool, but yeah.
So that's why you also live in Aachen still, right?
Maybe.
Joking aside, so you talked also about impressing success on this journey. For you personally, in the last 5, 6 years now, what was your biggest personal success when pushing this transformation?
So for me, there are 2 successes, although you asked for one, but nevertheless. So first of all, actually building something in-house that allows us to use AI. And when you finally have a patent for a new chemical product, and that comes also to the market, that is producing some EBIT, producing some income in the end for the company, that's really success. And you have set the technology foundation, and then there are people using it and people making use of what came out of it. So you have a whole chain, but you were in the beginning, you set the starting piece. And this is really one of the things where I feel, this is a success. Yeah. The other thing is, we managed to get away from a really big software supplying company where we had our data platform to something that we built in-house. Initially, people were like, can we achieve that? Can we get there? We measured constantly the satisfaction of the people. Yeah. It obviously dropped in the beginning. You don't have, after 6, 9 months, a ready-to-use product. And then it increased above to what we had at that point in time, way above that. And now it's stable, and now we're putting one level on top, and that at a cost which is not comparable to what we have. Now bringing it together with all the different systems, having a central platform and being able to react and produce something, that makes me proud. Yeah. So half a year to replace the former platform roundabout, if I understood correctly, it's 6 to 9? So we started converting after 6 months, then final conversion, really the head of, or the peak of the conversion was after 9 months, and then it took like 12, 15 months maybe. Yeah. But it's a full-time investment.
Well, but still, those are benchmarks, right? If you're gonna get, if you're trying to get rid of the software where you have your big login effect, maybe just talk to Martin. He will give you some insights on how to manage such a huge project. Thank you so much for sharing your insights.
Sure.
Today.
Thanks.